Now I have defined you an example. Yes, I have defined you an example of half series. Yes, now I have defined you an example of half series. That is, the example is, yes, which is defined as express f of x is equal to x as a half range sine series sine series in the interval 0 is less than x is less than 2. Yes, and also you express first one is, and also this is the first one, and also yes, also express f of is equal to x yes as a half range cosine series. Yes, cosine series in the interval 0 to 0 is less than x is less than 2. Okay, now we solve this question. Yes, solution of this problem. Yes, the Fourier series, earlier I have defined you also in this above the video. I have defined you the Fourier sine series, the Fourier sine series for f of x in the interval 0 to is f of x, which is equal to sigma n varying from 1 to infinity, not n, 1 to infinity bn sine n pi x by 2. Yes, earlier in the earlier lecture I have proved here an and bn as the f of x is said. Yes, here you see that bn is 2 by L from this one. Yes, similarly you can prove that in half series, and this is also for the half series. In earlier video I have defined you. So this is bn sine n pi x dx. So this can be written as where bn which is equal to here is 2 by bn is 2 by L, 0 to L, this one. So 2 by L, 2 by L is 2. So yes, for 0 to L, this is the problem is like that. So 2 by 2, 0 to 2, f of x sine n pi x by 2 dx. Yes, n pi x by L here is written as, here is the problem is n pi x by L. You can also, if you for the here is L is 2, so you substituting here is 2. Yes, okay students. Now if you calculating this term, then you get 2 and f of x is this one, and f of x is here is x. So bn is equal to 0 to L, 2 to cancel out, and here is fx is x sine n pi x by 2 dx. Yes, you can evaluate it. Yes, this integral you can evaluate, and now you get the result is, yes, evaluating this result, yes, you get, yes, okay. Now you get this one is equal to like f of x, you get f of x is equal to, you get which is 0 to 2 x sine n pi x by 2 dx. Oh yes, integrating this you get minus of, yes, 2x by n pi cos n pi x by 2 plus 4 by n square pi square, and here is again sine n pi x by 2, and in the limits from 0 to 2. Yes, minus 2x by n pi cos n pi x by 2, integrating this term. This integration of this is similar, differentiating this way. Now you get 4 by n square pi square sine n pi x by 2. So then you get the value for the limit 0 and 2. Yes, you get this is equal to minus of 4 minus 1 to the power n and divided by n pi. Yes, clear? So this is the, so f of x is equal to, for this f of x is this one. No, here is, this is the bn. Yes, f of x actually the sigma of this is not f of x. Yes, you have write down this is bn. This is bn actually. Last time I have defined you this one. This the problem is here is this. Now this is not f of x but actually bn of, yes, actually you write down this is as the, or you say that this is bn. Okay, you know, according to this one. So bn is again here. Okay, so bn is this one. Recording the function f of x, which is the Fourier series in sigma. So this one. So if you calculate b1, then b1 is, yes, 4 minus 1, 1, then 4 by pi. Similarly for 2, b2 is minus 4 by 2, then even 2 pi. And similarly b3 is 4 by 3 pi. Now so on. So you can therefore the half range, yes, you can say that the hence the required half range Fourier sine series, yes, sine series for the function f of x, yes, for f of x in the interval 0 to is first b1 b2 now so on. So f of x is, yes, this is equal to 4 by pi, yes, sine pi x by 2 minus 1 by 2 sine 2 pi x by 2 plus 1 by 3 sine 3 pi x by 2 plus up to so on. Yes, this is the sine series. Similarly, you get the cos series. Yes. Similarly, for the next part is, you have right here, for the next part is for the cosine series. Yes, the Fourier series for series for cosine series. Yes, cosine series for fx in the interval 0 to. Similarly, here is a0 is again, so the f of x is, which is a0 by 2 plus sigma n varying from 1 to infinity a n cos n pi x by, according to the formula you can write here is 2 n pi x by L, but here is L is 2, so you can write here is 2. Okay, clear? Now here a0, you can find out. Yes, first we have to find out a0, which is equal to 2 by 2. Yes, 0 to 2 f of x dx, and here f of x is, yes, 0 to 2 f of x is x dx, so you get this value is f of x square by 2. Yes, that is, you get the value is 2. Yes, okay. Similarly, you can find out an is again 2 by 2. Yes, 0 to 2. Okay, 0 to 2 f of x according to the cos, yes, n pi x by 2, L is 2 dx. Yes, so that this term become, this is again is equal to, here f of x is x, so this is 0 to 2, here x cos n pi x by 2 dx. Yes, clear? Now integrating, as for the, you have integrating earlier, here is b, and similarly for the an, this can you get the value is, this is equal to, similarly you can get 2x by n pi, yes, sine, yes, n pi x by 2 plus 4 by n square pi square cos n pi x by 2. Yes, limit from 0 to 2. So you get this value is 4 by n square, yes, pi square, and here is again is minus 1 to the power n minus 1, because you get the all the values of cos of n pi and this one. Similarly, this is an, so for an you can calculate what is a0, a1, a2 and so on. So according to this, if you calculate n is 0, n is 1, yes, so you calculate a1. a1 is minus 8 by pi square. Similarly a2, which is equal to 0. Similarly a3, you get minus 8 by 3 square pi square. Yes, similarly a4, which is 0, and if you calculate a5, then you also get minus 8, yes, and here is 5 square and pi square. Now so on, etc. Okay, these are the values for a1, a2. Now substituting the series, and now you get the result. Okay, substituting all this term, now you get the result. Yes, hence, yes, hence, yes, hence the required half range Fourier series yes for f of x in the interval 0 to, yes, in the interval 0 to, you can write down this is equal to substituting all the values, that is f of x, yes, which is equal to a0, yes, now so on, yes, a0 which is a0 by 2, here you see that a0 by 2 and a0 2, so this become 1, okay, so this is, here is, okay, here is 1 minus 8 by pi square, and here become cos n pi, yes, n is 1, so pi x only become, n is 1, so pi x by 2, yes, divided by 1 square plus cos 2 is 0, so 3, yes, 3 n pi x, 3 pi x by 2 and divided by 3 square, yes, plus cos 5 pi x by 2 divided by, yes, 3 pi, this one for this value is cos of this is, yes, this value cos of, yes, divided by 1 square, 3 square, similarly this divided by, yes, 5 square, now so on, yes, because substituting here all the values is here an, a0, a1, a2 cos of n pi x and divided by 2, yes, so all the series you get the term is a0 is this one 8, a2 is 0, a4 is 0, so all these values are this one, yes, so n pi x, this is again become only this term, all these angle is this one, now we get this, and similarly this one, yes, this is the half range Fourier series in the interval 0 to, yes student, you have cleared this question, okay, again I have to find you some different type of the Fourier series, some problems, okay, thank you students.